Hey, welcome to the notes for graphing logarithmic functions. And before watching this video and taking notes, you want to make sure that you've completed the math lab on Schoology to introduce logarithmic functions and their transformations. And all we're really doing then in these notes is summarizing what you discovered in that transformations lab and then working through some examples together. So in the lab we learned that log base 2 of x is the inverse of the exponential function y equals 2 to the x. So in the graph that we see here, recall that inverse functions are a reflection over the diagonal line y equals x. So as we reviewed in that math lab, any point that's on the exponential function y equals 2 to the x, for example, this anchor point 1, 2, right? If I reflect that over the line y equals x, then on the inverse, the corresponding point switches the x and the y coordinate and becomes 2, 1. And similarly, if we look at the point on y equals 2 to the x, the exponential function has a y-intercept of 0, 1, then the corresponding point on the log base 2 of x, since they're inverses, switches that x and y, and we have the point 1, 0. And then our third anchor point on the graph of 2 to the x is -1 reciprocal of b, and the b is 2, so -1, 1/2. So when we reflect that anchor point, we get this point here at 1/2, -1. Okay, so when you open up to the first page on the inside, you'll notice that the parent graph then of log base b to the x always passes through the same 3 anchor points as y equals b to the x, only we're switching the x and y. So our guide points, instead of going through 1, b, are going through b, 1. Instead of the y-intercept being 0, 1, now the log base b of x has an x-intercept of 1, 0. And then our third anchor point, instead of being -1, 1 over b, we switch the x and y and get 1 over b, -1. Okay, the vertical asymptote for the parent graph is going to be along the y-axis, so that's the equation x equals 0. And the domain is half-bounded from 0, non-inclusive, to positive infinity. The range is fully unbounded, -infinity to positive infinity. So our transformations of logarithmic functions, in transformation form, the a, the b, the c, the h, and the k, each will produce a different transformation on the function. The k and the h are the rigid transformations, so x minus h is going to shift the graph to the right h units. X plus h shifts the graph to the left h units. A positive k shifts the graph up k units, and a negative k shifts the graph down k units. Okay, the a and the c are going to control reflections, which are also rigid transformations. So if the c is negative, that's a reflection over the y-axis, and if the a is negative, that's a reflection over the x-axis. The a and the c also control dilations, which are non-rigid transformations. So if the a is greater than 1 in absolute value, that's a vertical stretch. And if the a in absolute value is less than 1, which would be a fraction between 0 and 1, that's a vertical shrink. Then if c in absolute value is greater than 1, that's a horizontal shrink. and if c in absolute value is less than 1, which is a fraction between 0 and 1, that produces a horizontal stretch. Okay, and those transformations are all exactly the same as what occurs for any parent function. We use these same transformations for exponential functions, square root functions, rational functions, polynomials, all of them. The thing that was different, if you recall, about the exponential is also different about the logarithm, and that's the b. So our transcendental functions, the exponential and log, have a b, which is the base, and that b is used to identify these 3 guide points on the graph, the x-intercept at 1, 0, b comma 1, and reciprocal of b comma negative 1. Okay, the special thing about logarithms is that when your base is 10, that has a unique name called a common log. And when your base is e, and we'll talk about e in more detail in the next lesson, that's called a natural log. Okay, when you look at your graphing calculator and you find that log button right here, okay, the log button on your calculator is always a common log. It's a base 10. So you cannot use that button to graph a log base 2 or a log base 4, right? Only the button is used for common log, which is base 10. The one under it that says ln, right, that stands for natural log, and that's a logarithm of base e. And you can remember that if you look right above in the blue paint there, it says e to the x, right? The natural log is the inverse of e to the x. Same thing for the log button up above it in blue paint, it says 10 to the x, and a common log is the inverse of the exponential with a base of 10. So these 2 buttons on your calculator, just remember the log is base 10, the ln, the natural log, is base e, and those are the only 2 bases that you can graph in the calculator. You can't graph them if they have another base other than 10 or e. For example, log base 2 or log base 4.